Hey everyone, welcome to evaluating the definite integral. We're going to be using geometric areas today. This is Nicholas JMV. So let's go ahead and get started. So on your AP exam, you're probably going to be asked to calculate the area under some type of curve that you can do it geometrically. And geometrically mean by shapes like a triangle, rectangle, circle. So I could evaluate this by hand. Okay, I could plug it in my calculator and do it, but we're not going to do that. We're going to actually be using a geometric formula. Okay. So we're looking to integrate from -3 to 3 of this square root of 9 minus x squared, which I have graphed for you already. Okay, so it's a semicircle. So here's the idea, the geometric formula. We know that the area of a circle is pi r squared. Okay, but in this case, okay, we want the area under the curve from here, -3 to 3. Okay, we only have half of the circle, so our area equation is going to be 1/2 pi r squared. Okay, so when I look at this, the first thing I want to do is I want to look for my radius from the center, okay, out to the boundary, which is a distance of 3 units. So my area is going to be 1/2 pi times my radius squared, and my radius in this case is 3. So my final answer for this particular question is 9 pi over 2. That's the area. Okay, and this would also be the total area because all the area is on the positive side of the axes. Okay, so that's what we mean by using a geometric formula, okay, instead of using like our rules for definite integral and our rules of integration. So let's look at another example. So number 2, we're going to evaluate the integral from the 0 to 6 of x minus 4 dx using a geometric formula. So this is a absolute value function, and it's not going to be differentiable at 4. Okay, so here's the idea. I can look and say, okay, if I look at my geometric shapes here, let's see if I can fill this in without getting... Okay, I have this geometric shape I can fill in right here. That triangle. There's one triangle here. Okay, and let me pause right there. Okay, sorry, we're back. The world of a teacher. Okay, so we have one triangle here, and we're going to have to use an integral if we're going from 0 to 6. So we're also going to go right here. And we have this other little triangle here. I guess I could try to fill this in. So we have two triangles here, okay? And the area of a triangle is equal to 1/2 the base times the height, okay? And these are right triangles, so this is going to be really nice for us to do. So let's do the one in green first. So our area is going to equal 1/2 the base. The base is from 0 to 4. And the height is also from 0 to 4. Okay? So that's going to simplify. 16 over 2 is 8. And then if we looked at the area of our red triangle, it's a little smaller. 1/2 the base, which is from 4 to 6, which is 2. And the height is from 0 to 2, which is also 2. So half of 4 is 2. And you take that sum together and we get a total of 10 units, or the area is 10 square units. Okay, so 10 units squared is our area. Okay, so that's example number 2. Let's go on to our third example, and I really like this one. Okay, this one's a little bit different. I used trapezoid rule once today for this. But let's graph the integrand from -2 to the integral from -2 to 4 of the x over 2 plus 3, and use geometry to evaluate the definite integral. So you might see it worded like this. So here's our integrand. If you don't know that already, here's the integrand right here. We're gonna draw that, and I've done that again for you in red here. So here's what you can do. So first thing you might want to do is draw the line down. Okay, and that's a height of 2. And we can go ahead and I'll do a dotted line so I can keep it straight. And that height looks like 5. Okay. Now what I did is I went through, and one way you can do this is you can do trapezoids. Okay, so I went ahead and did trapezoids like this the first time. Okay, and was like, well, there's got to be an easier way. So I went ahead and I did trapezoids, and I thought, well, there's an easier way to do that, okay? So you could do trapezoids. That's one method, okay? But that's not the only method, so I'm going to go ahead and clean this up. Watch what happens if we go ahead now and kind of just draw this up to 5 and go straight across. What I have now is the whole thing is a rectangle. Okay, this whole thing, we have this big rectangle, and I've got this smaller triangle. So let's look at the area of the rectangle, the whole thing, the whole thing first, okay? And that's going to be the length times the width. So the length is from -2 to 4, which is 6 units, times my height, which is 5 units. So the whole thing has an area of 30. Okay, but I don't want the whole thing. I only want that red portion. I have to cut out this purple portion right here. Okay, this guy, all through here. I got to cut that out. I don't want that piece in there. Well, nice that it's a triangle. So we know that the area of a triangle is 1/2 the base. So 1/2 my base from -2 to 4, which is 6 units. My height is from 5 to 2, which is 3 units. So that's 18 over 2, which is 9. So the total area of the red, the area is going to be equal to 30 minus 9, which is 21. 21 units squared if you want to write that, okay, but the area is 21. Okay, so those are a few examples of using geometric formulas there to find definite integrals. So if you have any questions or comments, go ahead and type them below, and we will see you next time.